So in this tutorial, I'll be showing you how to use the SMC L298N PID driver module with ros2. So that's what this tutorial is all about. I'm showing you how to use it with ros2. Now, please note, I'm going to be connecting, or now I'm going to be using it just with my PC, not with the Raspberry Pi. I'll be doing that later in future tutorials. I've not mounted the Raspberry Pi, so I'm just going to be testing the idea with my PC just to see how it's working. If the module is working all right. So that's basically what I'm going to be doing. So the first things first, I'm going to connect it to the USB port via the FTDI module. I'm going to connect it to my PC. We also do the same thing to the Raspberry Pi. For now, I'm going to be using PC. It is my USB port, which I'm going to connect. So once it is connected, I'll also power it. Yeah. So once I power it, that means the board is actually powered. If you follow the setup process, I think you understand what I'm saying. The board is powered, and this FTDI is connected to what your PC or your computer that is Raspberry Pi. So that's just the basic thing. Now, before I continue, remember, I assume that you understand at least some ROS concept like publishing, subscriber, using RVs, at least some basic setting up ROS workspace and things like that, ROS depths and things like that. So I'm not going to be covering those basics here, just how to use it with ros2. So just follow on. So another thing I want you to take note of is that you should ensure that you have set up the PID parameters of this particular module and this motor. Please, if you have not done that, just follow the tutorial that explains how to do that. Before you are doing anything on this ros2, ensure you have set up the PID parameters, the encoder, and all those things using the setup application. So that's one thing to take note of. Also, note that this is correctly implemented with ros2 ros2 with Ubuntu 22.04. To set it up with ros2, we'll be needing two packages. The first is the actual ROS plugin package for the SMC L298N PID driver module. This is the ROS plugin. You can get it from this link. Or if you look at you look at the documentation on my website, you also get it there. Two packages. This is the ros2 plugin and also a test robot, which is the SMC diff bot. To test it, which you understand how we are going to do that later. So this is the test robot and the actual plugin, the control plugin. So first we are going to be setting up the plugin in the next video you see. So once that is done, the next thing is to also install this or set up or install this test robot, which is the SMC diff bot. Yeah, remember, it's just a robot designed to help test the ros2 plugin. The differential robot that is designed to test the ros2 plugin, which you can also use in any of your robots and does a quick test. You can use it in any of your robots and you can build up on it. You can use this URDF file, build up on it to maybe build your own robot also, or know how to set up ros2 control with this mode on your robot. So that's just what it is meant for. So I'm going to be following this process to set up the robot that will now go into how to use the ros2. So that if all has been done, you should have properly installed these two packages in your ros workspace. This is my ros workspace. So to use it, I'm going to go into this SMC diff bot. So to test the SMC diff bot now with the SMC L298N driver connected. So that's where I'm going to. Yeah. So the first thing is to run. You can view the robot by running this code. Just to view the robot, you can just build how the robot looks like. So I'm going to be opening a terminal here. I'll be sourcing it. So I'll source this my workspace. I'm going to source it. I'm going to run this command just to view the robot in RVs. Yeah. So this is how the robot looks like in RVs, the left to right way. So this top part is the IMU. Well, I'm not using the IMU in this tutorial. So, but You will be seeing how the controlling the left and the right way with the base link. So that's really well, but this does the robot. So we have viewed it, you can close that. So the next thing is, now I want to start the SMC input with the ros2 plugin. So since everything has been installed, you can run this robot server control. Remember, this mode has to be connected to the serial port of my PC or microcomputer to run this. Yes, this is server, and this is the code that is to run on your PC, or if you are using Raspberry Pi, this is the code that will be running on your Raspberry Pi. So I'm going to launch this. I'm going to launch it. So you notice it will connect to the module. The module has started. Yeah, and take about 5 seconds. Oh, okay. It says it's not available yet. Okay, so I think the first thing I need to do is to check where it is connected to. The USB it is connected to. I might need to check that to see if I'm connected to the right USB. It's connected to the right USB. I'm going to go to this port, the URDF file. So first confirm if it is connected to the right USB port. Yes, USB TTY0. When I'm doing the Raspberry Pi, I'm going to explain this by path subject. So, but since everything is connected, it has been placed, let me run it again. Let's see if it should run now. Yeah, so everything is now properly working. Joystick, broadcaster, diff drive controller, and everything has been activated. So I'm going to source this workspace in that tab. Then I'm going to run the robot client view. So just to view the robot while I'm driving. That's what this is for. Yeah, do odometry data and things like that. I'm going to run it here. Yeah, so now this is the robot. Now if you notice, the blue light is on, it's blinking, which means the serial data is being transferred between the PID module and my PC. So I want to run a driving package. Now you can use teleup twist. I really don't like teleup twist. I wrote a package that just make my life much easier because I like to use the arrow keys to drive my robot. So also no arrow. So ros2 on arrow key teleup drive, arrow key teleup drive. So I want to move at velocity 0.08 and angular velocity 0.5. Yeah, so once I've started the arrow key teleup drive, I'm going to click on this. I'm going to drive it now. You should notice the wheels will be moving now. Exactly. And it's making the robot is moving. Note the movement. That's really how to use it with the ros2. Good. Now you see that it's working with ros2. Yeah. You can close everything once we are through. So once your USB is connected, if you didn't connect the first time, can always run the server control again if you connect. So the thing is that you can now go over the code, see how I wrote my launch files. So in case you want to use it in your project, you can always check out the different launch files and see how you can set up your own URL file using this ros2 control. Just follow the same pattern, the same process. But that's really how you get used to it. Copy the code and use in your preferred robot, or you can just build on this particular code and use it in your own robot. And you also see the server control file, you see how I called the controller manager, the topic, how I am remapping the topic to the normal command velocity that we know. So a lot of things is there, so you can always check the code and use it however you want to use it. So that is that for the setting for using the SMC L298N PID driver module with ros2. Yeah, thank you.